Lesson 3.4, we're looking at proofs with perpendicular lines. And most of this is going to feel very straightforward. There's not much that's too shocking here. You could go ahead and do this if you'd like, if you fold a paper twice and think about, think about what's happening there. Do you all know when they say AB, you all are aware that that's this segment? And then CD is this segment. And you can think about what conjuncture. Now, conjuncture is obviously just based on the observations of as you fold them and what's going to happen. Okay. And then as you fold them, hopefully you realize that this makes a right angle. And then because of the way it's folded, maybe you realize that AO and OB are congruent. And do you think that DO and OC are also congruent? Now, here's the start of we got to be careful. You notice how I added 2 tick marks on the OC and the OD? And that's because usually a paper is like 8 by 11 or whatever. So this would be 4 and this would be 4. And then this would be 5.5 and this is 5.5. By putting 2 tick marks, that's telling the reader that these 2 pieces are congruent and these 2 pieces are congruent, but not all of them are the same. Okay? And then you can justify it by using measuring tools or however you'd like to do it. Okay. You could do that one too if you'd like. This, if you have the tools at home, this is an interesting thing. I can't do it on here. All right, my internet, I think it's still working. Anyways, you can try these if you like. There's probably apps you could have that would do the same things. But here's our core ideas here. So we're on that page 83. We're looking at the distance from a point to a line. And if I have a line and I have a point P not on the line, and I want to know what's the distance, which line would you use to measure? Would you use this blue line to measure the distance? Would you use this red line? Would you use this green line? Which line would you use to measure the distance? Well, the line you should pick is the red. So when we measure the distance from a point to a line, we want it to be perpendicular. So we want it perpendicular to the line through the point. Perpendicular bisector, well, perpendicular means that you make a right angle. Bisector means to cut it in half. So if I have some segment, here's my segment, AB, I need a midpoint because I had to bisect it. And then my perpendicular bisector is going to pass through that point and it's going to be perpendicular. So my purple line, P, is the perpendicular bisector of AB. P is perpendicular to AB, and the other thing that has to happen is that let's call this M, AM is congruent to MB. All right, so we got some theorems. The linear pair perpendicular theorem. Now, before you even think about it, if 2 lines intersect to form a linear pair of congruent angles. Okay, first of all, linear pair means that they have to be 180, right? If they're congruent, they got to be equal. So they both have to be 90 degrees. If these are both right angles, then isn't that what it means to be perpendicular? Perpendicular lines intersect to make a right angle. Okay, that's the idea behind that proof. I just kind of talked you through how you might prove it. Okay, the perpendicular transversal theorem in a plane, if transversal of a, good Lord, try reading again, Mr. Raftery. In a plane, if a transversal is perpendicular to one of the 2 parallel lines, then it's perpendicular to the other line. Now, if you understand how slopes work back from algebra, if I have 2 parallel lines, right, if I have two parallel lines, and let's say my slope of this line is 3, then the slope of this line has to be 3, right? Now, in order to be perpendicular, perpendicular lines have opposite reciprocal slopes. So, to be perpendicular to the one, the slope has to be the opposite reciprocal. It has to be negative 1/3. So then this also has to be negative 1/3. So it's going to be perpendicular to both. The other way you can think about it, so that's using more of your algebra from before. The other way to think about it is say, okay, if it's perpendicular here and these lines are parallel, do you agree corresponding angles are congruent? Yes. Once you have the right angle, you know the lines are perpendicular. In a plane, if two lines are perpendicular to the same line, they are parallel to each other. And again, that's kind of almost the flip of this one, right? So here we're saying they're parallel, and so it's perpendicular to both. Here we're saying they're perpendicular, so they're parallel. This one's real simple. It's just saying, hey, well, look right here. These are corresponding angles. If corresponding angles are congruent, then bingo, your lines are parallel. Real simple. All right. So it's more so the concepts. Then we get into the little bit of math here, and this is very redundant on the book's part, but on the flip side, one of the things you struggle with the most is distance, so we're going to do some practice, right? We want to find the distance from point A to line BC. Now, for me, I look at this and there's a lot of stuff on this graph. I'm just going to look at number 1. So I'm going to expand this a little bit. I'm just going to look at number 1. So I'm going to make a note. This is the one that I want. I want it perpendicular to here, and I want it passing through that point. So should I pick the red line, the purple line, or the green line? Which line would give me the distance from the blue point to the blue line? And the one that would give it to me is going to be this, the AD, okay? So I'm going to find the distance of AD. To find the distance from the point A to BC, I need 2 points. Remember distance formula? That equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. It also is the same as a squared plus b squared equals c squared. You can think of it either way. So I'm going to make a note. A is at negative 3, 0. D is in dog, is at negative 1, negative 2. So I'm going to subtract, I'm going to do the distance formula. So I'm going to take my x's, negative 3 minus negative 1 squared plus the y values, which is going to be 0 minus negative 2 squared. So this is equal to negative 3 plus 1 is negative 2 squared plus 2 squared, which is equal to the square root of 4 plus 4, which is equal to the square root of 8. Now we get to the square root of 8, that's fine, but you really want to be able to simplify. So 8 is 4 times 2, so I'm going to simplify the radical. So I'm going to do 2 square roots of 2. That's the distance. I would strongly encourage you, pause the video and try the next one on your own. Okay, try number 2. So again, we're looking for the distance from A to that line BD or BC. So the one I'm going to focus on is the one that makes the right angle. So in that case, that's going to be this one right here. So again, this time I'm going to do Pythagorean theorem just in case there's some of you that like that method. Instead of the distance formula, I'm going to just show you the rise and the run here. The rise, I'm going from negative 4 up to 2. That's a change of 6. The run, I'm going from negative 3 to positive 3. That's a change of 6. So Pythagorean theorem, I basically created a right triangle where this is 6 and 6, and then this would be my c. My c is always my hypotenuse. So c squared equals a squared plus b squared. So c squared is going to equal 6 squared plus 6 squared. So c squared is going to equal 52, right? 36. No. Yowza. Holy Hannah, how about 72? So now I have c squared equals 72, so I'm going to take the square root. 72, when I look at 72, 72 is a little bit tricky. You got to be careful. We want to make sure we pick the biggest perfect square to go in there. So perfect squares are like 4, 9, 16, 25, 36, 49. That's 7, 8 squared is 64, 81, 100. To find the biggest, I like to start with the number that's just smaller than 72. So 49. Does 49 go into 72? No. Does 36 go into 72? Why, yes, it does. 72 is 36 times 2. Square root of 36 is 6 square roots of 2. This is the length of AD. Pythagorean theorem. Okay. Number 3. Try it. Pause the video. Give it a shot. Going from here to here. The one I'm going to pick is going to be this one because that's perpendicular. Okay, so this time I'll do the distance formula like before. So my one point is at -3, 3. My other point is at 1, -1. So distance equals the square root. I'm going to subtract the x's, -3 minus 1 squared. I'm going to subtract the y's, 3 minus -1 squared. So this is -4 squared. This is going to be 4 squared. So this is the square root of 16 plus 16. No, somewhere I screwed up. Oh, snap. You know where I screwed up this time? Oh, jeez. I screwed up right here. That should have been a -3. Look at that. This is, ugh. Oh, I hate that. And I don't have time to do a video. All right, well, anyways, look at how human Miss Raftery is. Who knew? -3 minus 1 is -4. -3 plus 1 is 2. This is another reason why, I'm going to show you something. It's another reason why I like Pythagorean theorem. When I think about, when I trace this in, like even if you only use it just to check, this is 2, this is 4. So I knew I had something wrong when I had these being the same or those being the same. That was like an alarm in my head. I knew something was wrong. Okay. And that's kind of a big deal. Like that's important. So here, this is the square root of 20. The perfect square in 20 is 4. 4 times 5. So that's 2 square roots of 5. How about number 4? Which one would you pick? The one that people want to pick is this one. But is that perpendicular to this line? And your answer should be no, we don't want that one. We actually want this one. Okay? So now, again, I'm going from this point to this point. So if I make a little right triangle, I'm looking at 1 and 2. 1 and 2. Pythagorean theorem says 1 squared plus 2 squared equals c squared. So I have 1 plus 4 equals c squared. So c equals the square root of 5. If I don't like that, I can do the distance formula. Distance equals the square root. I'm going to subtract the x's. 1 minus 3 squared plus 3 minus 2 squared. So here I have -2 squared plus 1 squared. So this is going to be 4 and 1. This is still the square root of 5, either way. Alrighty, that is not it. I'm going to stop this video and we'll start a second one.